Hey there kiddos, here's your video over simplifying radicals. I'm going to try and keep it short and sweet so that this doesn't have to be a really long video. If you've got your calculator, it will come in handy, so you might grab it and get it out. So all we're going to be doing is simplifying square roots. So today in class you solved quadratics using square roots, and then next week we're going to solve quadratics using something called the quadratic formula, and both of them use square roots and radical symbols when they're doing them. So we're going to learn how to simplify a square root. So a radical sign is just the square root symbol. It's the symbol that we use to identify that it's a square root or a root of some sort. Radicand is the expression under the radical, so it's the number that's in here. And you'll hear those words sometimes used, but just so you know. So what I want you to do real quick is I want us to fill in this table and list the perfect squares for numbers 1 through 10. So for example, 1 squared is 1. 2 squared is 4. I want you to pause the video for just a second, fill in your table, and then come right back. So hopefully you've got your perfect squares listed, and so all of our perfect squares are listed right here. So the perfect squares are 1, 4, 9, 16, and so on, and their square roots are over here. So the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. This will come in handy as we're going through some of our problems here in just a minute with simplifying, because you're going to have to know what your perfect squares are in order to simplify. So we're going to skip directly over here to some properties of radicals that I want you to write down. The square root of a divided by b can be separated into two different square roots. It can be separated into the square root of a divided by the square root of b. And so I can simplify it that way and take the square root of both pieces individually. The square root of a times b is the same thing as the square root of a times the square root of b. So I can separate it and also do those square roots individually. Now this last one, the square root of a, the whole thing squared, just like when we solved problems using square roots. A square root undoes something squared, and it works the opposite. Squaring something undoes a square root. So if I'm going to square a square root, it just becomes the number under the radical. So it just equals whatever is under that radical. So let's do some examples. So if I want to simplify a square root, for example, this square root of 3 over square root of 49, I'm going to split it up first using those properties we just talked about into the square root of 3 over the square root of 49. So I have two different radicals. Well, the square root of 3 is not a perfect square, and it's a prime number, so I'm going to leave it as the square root of 3. But 49 is a perfect square, and the square root of 49 happens to be 7, so this simplifies to radical 3, or square root of 3 over 7. Example 3, same thing. Let's break it up into its two parts. Square root of 5, again, is a prime number, so nothing happens to that. But square root of 36 happens to be 6, so this is what it simplifies to. Now sometimes our square roots don't simplify nice and pretty like square root of 49 or square root of 36. Sometimes I have a number like 75, and I need to simplify that. Well, the first thing I need to do is break up the square root of 75 into two numbers that multiply to make it. But it's not just any two numbers. It has to be two numbers where one of them, at least one of them, is a perfect square. So the first thing I'm going to do is list all the factors of 75, and if you don't know what they are off the top of your head, you can grab your calculator. You can go to y equals, and you can take the number, which in this case is 75, that you want to find factors of, divided by x. And if you go second graph and look at the table, starting at 1, and you can list all of the whole number factors you see. So I'm going to list all of my whole number factors of 75. And so I have 1 and 75. I have 3 and 25. And I have 5 and 15. Those are it. There are no more whole number factors, because if I keep going, I finally get down to 15 and 5, but that's just a repeat of this. So now I want to look in this table for all the numbers that are perfect squares, because I need a perfect square in order to simplify this. Well, over here on the right, I got 1, 3, and 5. All of those are prime numbers. None of those are perfect squares. Well, 1 is a perfect square, but so I guess that one is a perfect square. But 3 is not, and 5 is not. Okay, so this is potentially the pair of numbers that I'm going to split this into. So now look at the right-hand side. 75 is not a perfect square, although 1 is, so we're going to leave that. 25 is a perfect square, so that's good. 15 is not, however, so this one I don't need. So it's one of these two pairs of numbers, and how I know which one to use the one with the larger perfect square. You want the biggest one possible. That way when you simplify, you don't have to simplify again. So I'm going to break up the square root of 75 into the square root of 3 times the square root of 25, because according to my properties, they're the same thing. I can do that. And then I'll just simplify. Well, the square root of 3 we've already discussed. It's not a perfect square, so it's going to stay the square root of 3. But the square root of 25 is 5. So I can simplify that. Well, to rewrite this so it's in notation like I'm used to seeing, I'm going to rewrite it as 5 square roots of 3. And so we can check in our calculator, and you can see that these really are the same thing. If you use your calculator and you do the square root of 75, you get this long decimal. And if I happen to do 5 square roots of 3, that's the same number. So these are identical. These are the same thing, only written in a different way. It's like taking 2/4 and simplifying it to 1/2. They are the same thing, one's just simplified. So that's all I'm doing. I'm just simplifying what I have. So let's do example 5. I've got the square root of 98. So I'm going to list all the factors of 98 just like I did a second ago. So I'm going to do 98 divided by x. I'll go look at my table. And it looks like I have 1 in 98, 2 in 49, 7 in 14, and I'm pretty sure that's it. So 1 is a perfect square, 2 is not, 7 is not, 98 is not, 49 is, 14 is not. So this pair doesn't work, and this one contains the largest perfect square, so it's the one I want to use. So I'm going to split this into the square root of 2 times the square root of 49. So this becomes the square root of 2 times 7. So I just write it as 7 square roots of 2 for my answer. So now what happens if the thing I'm trying to simplify already has a number in front of the radical? Well, let's talk about that. We're going to ignore the 6 on example 8 for just a second, and we're just going to simplify the square root of 48. So I'm going to do what I did before. I'm going to list factors of 48. So I got 1 in 48, 2 in 24, 3 in 16, 4 in 12, 6 in 8. So if I go down the right-hand side, 4 is the only perfect square. And if I go down, sorry, that's left. If I go down the right-hand side, 16 is the perfect square. Well, the one with the largest perfect square is this pair of numbers, so I'm going to split my 48 into 3 and 16. So I'm going to keep the 6, and 48 is going to become the square root of 3 times the square root of 16. And then I'll simplify, so 6 stays a 6, square root of 3 stays square root of 3, but square root of 16 becomes 4. Now, since this is multiplication, these are numbers. I can go ahead and multiply them together. 6 times 4 is 24. Keep your square root of 3, so my answer is 24 square roots of 3. And if I put this and this into my calculator, they will come out and equal the same thing. This is just simplified where this is not. So example 9, same thing. We're going to do the square root of 32. So factors of 32, 1 and 32, 2 and 16, 4 and 8. Pretty sure that's it. So 4 is a perfect square, 16 is a perfect square, and 16 is the bigger one, so I will use this. So I'm going to have 2 times the square root of 2 times the square root of 16. Well, the 2 and the square root of 2 are simplified, but the square root of 16 becomes 4. Multiply your two numbers together, so you get 8 square roots of 2. So a couple more. Example 10 here, I've got stuff in parentheses and it is squared. And we talked about how squaring something undoes a square root, but this isn't just the square root of 6. There's a 3 multiplied in front of it. So what this means by doing this squared is that I'm actually doing 3 square roots of 6 times 3 square roots of 6. And so I have to multiply, I'm going to multiply them all together. So 3 times 3 makes 9. And when I do square root of 6 times the square root of 6, that's actually the square root of 36. Well, the square root of 36 is 6, so this really becomes 9 times 6, which is 54. Now, if you don't want to write it out this way, that it's this times itself, here's what you can remember. Distribute your little exponent to everything. So if I do 3 squared, I get 9. If I do the square root of 6 squared, I get 6, and 9 times 6 makes 54. So like 11 here. 4 squared is 16. The square root of 5 is 5. That's not really what I said. The square root of 5 squared is 5. And if I do 16 times 5, I get 80. And so 4 square roots of 5 squared is equal to 80 because I did 4 squared and then I did square root of 5 squared. So that is simplifying radicals. You're going to practice this when you come to class tomorrow, and I'll see you then.